Welcome back to Smith Coding and Design. We are going to continue the tutorial series to make our GoPro mount. Today we're going to get into thread milling. It's slightly convoluted, so bear with me. Like in the previous tutorial, we are going to jump into a PowerPoint presentation where I will try to describe some of the numbers that we're using when we set up the toolpath, and then I'll also mention the use of the John Saunders from NYCNC spreadsheet that makes calculating these values easy. That's what I use, and I suggest that everyone take a look at that. It's free. So we will go ahead and go into 2D thread. We'll go to our library and into my Tormach tool library, and we will select the 1/4 thread mill. I will select OK. And now for our speeds and feeds, we're running at 5,000 RPM, just right around 1 thou per tooth, and we are going 20 inches a minute. So you'll see in the simulation, we're just going to plunge down into the center of our hole and then perform a helical entry moving upwards to cut the threads. We'll go to geometry. We'll select the hole in the center that we want to thread. And now we'll look at our heights page, and again, this is important. So for this scenario, I'm going to thread from the whole top to the whole bottom. That is fine. And now why I say this is important, because your thread mill will typically have a neck on it, and it will specify how deep of a hole that you can thread. So you want to make sure that you don't try to thread deeper than what your thread mill can actually cut, else you will crash your machine or break your thread mill. Again, I always sweat when I'm thread milling because thread mills are expensive. I mean, you're talking anywhere from $50 range into the hundreds of dollars, and the tips on the thread mills can get very small, so you don't want to break them and waste money. For retract height, I'm just going to go ahead and choose the model top. Now what I'm going to do is go into our passes tab, and here's where things will get a little interesting, and I will explain these numbers here in a minute again in PowerPoint. So we want our thread pitch to be 50 thousandths, which is correct. And then what we'll go ahead and do is change our pitch diameter offset, and I will explain this in detail here in a minute, to 0.0557. All right, and I'll explain how I got that value here in a minute. I will also go to multiple passes, and I'm going to take 3 passes at 15 thousandths. Okay, so that all looks good to me. I'll go ahead and press OK. Fusion will go ahead and generate the toolpath for us. So we can just right click and simulate. I'll just go ahead and use a timeline here so you can see we're going to plunge down into the center of that hole. Let me orbit a little bit. There we go. And then we'll just go all the way down and then perform that helical interpolation upwards, cutting the threads. So there we go. So that's how our thread milling is going to work. So let's go ahead and jump over to PowerPoint, and I will explain how I came up with the pitch diameter offset and the thread pitch. So let's go ahead and do that now. All right, here we go. So the first thing you're going to want to know about the threads is the TPI, or the thread per inch. So for a 1/4, there are 20 threads per inch. So our TPI is 20. Now in Fusion 360, you saw we needed to enter the thread pitch. The thread pitch is simply the spacing between the threads, and how we calculate that is really just 1/TPI. So again, our TPI was 20, so 1/20 gives us our 50 thousandths for our thread pitch. Now the next thing we had to enter was our pitch diameter offset, and typically what that is the major diameter minus the minor diameter. So we can look here at the image of the thread. You see our major diameter would be essentially the total width of the threads. In our case, that would be a 1/4 inch, and the minor diameter is on the inside, which would be the diameter of our drill, which is 201 thousandths, 0.01. So to find the theoretical pitch diameter offset, we would take the major diameter and subtract the minor diameter. So I have a little diagram here. So in the purple, this is where we came in and we drilled our hole. And the orange is where our thread mill would perform that helical interpolation and cut our threads to. That offset between the two is a pitch diameter offset. And so in our case, the major diameter again is 1/4 inch, and our minor diameter was the 201 thousandths. So if we subtract that, we get 49 thousandths to be our PDO, or our pitch diameter offset. And again, that is theoretical. Why? Because thread mills do not come to a sharp point. There is usually a crest or a flat portion of the thread mill at the very tip. And unfortunately, when I first started experimenting with thread milling, I found that especially with the cheaper manufacturers, which is, what I tend to buy, and I'm sure what you guys tend to buy as well, they don't list the crest or the flat at the tip of the tool, so it's kind of hard to guess and get a correct pitch diameter offset so that you can mill your threads properly. So what I found helpful was the spreadsheet from NYCNC, or John Saunders. And so let's go through how we use that to get the actual pitch diameter offset we use in Fusion 360. So if you download this spreadsheet, the first thing we're going to do is go to internal simple. We're going to enter our major diameter, which is our 1/4 inch, and then our minor diameter, which was the diameter of our drill, 0.201 or 201 thousandths. The next thing we need to do is enter the diameter of our thread mill. So the diameter of my thread mill is 180 thousandths. So that's what I'm going to enter there. Now this is where it gets tricky, because the vendor of my particular thread mill, I used Online Carbide. At the time that I bought this thread mill, I haven't checked their website recently, they do not provide the flat length or the crest. However, what we can do is go over in the spreadsheet and we can enter our cutting diameter. Again, mine is 180 thousandths, and the NYCNC spreadsheet here gives you an estimate of what that flat length would be. So if we take that estimate, we go back to our internal simple and we enter it here, and then we actually get the correct pitch diameter offset that we should start with in Fusion 360, which is where we got the 0.0557 that I entered. All right, so now we're back in Fusion 360. We'll just finish off here by going into our toolpath. We'll highlight that we determined how to calculate the thread pitch and the pitch diameter offset using the NYCNC spreadsheet. The last thing I want to do is go ahead and enable repeat passes. So we'll just repeat those passes in case there was any tool deflection when we were doing our thread milling. We can go ahead and help account for that with the repeat passes. So that does it. What I'll do is I'll just go ahead and press OK, and then we'll transition into some machining on the Tormach, where we actually will do the thread milling. Thanks for tuning in. Alright, here's the thread milling being performed on the Tormach. We plunge into the center of the hole. We do a helical interpolation upward, cutting the thread, taking 3 passes at 15 thousandths. That does it. Thanks for tuning in, and I'll see you next time.